Somewhere in development, on-delete cascade quietly goes missing from the task model's relation to project. Maybe a merge conflict resolved the wrong way, maybe a manual schema edit. Video 15's tests don't notice because they mock Prisma. They were never going to catch a mistake inside the schema itself. Video 14's tests don't notice either, for the same reason. The bug ships. A user deletes a project. The project vanishes from their dashboard. Looks like it worked. But the tasks that belong to it are still sitting in Postgres, orphaned, referencing a project ID that no longer exists anywhere. Nobody notices until the database itself starts complaining, or someone runs a query that surfaces rows that shouldn't be there. That's the blind spot every mock test has, by definition. Mocking Prisma proves your code calls the right method with the right arguments. It can never prove the database actually behaves the way you assumed. Integration tests close that gap. Real Prisma client, real Postgres, a disposable test database that gets wiped clean between every single test. Let's get intimate. Why mocks can't catch this? The line between a unit test and an integration test. A unit test asks, does my code do the right thing, assuming Prisma behaves the way I think it does? An integration test asks a different question entirely. Does Prisma against my actual schema actually behave that way? Cascading deletes, unique constraints, foreign key enforcement, none of that logic lives in your code at all. It lives in the schema and in Postgres itself, and a mock can't verify a single line of it. Setting up an isolated test database. Step 1. A database that only tests touch. Docker Compose test YML. Services, testDB. Image Postgres 16. Environment, Postgres user test. Postgres password test. Postgres DB. Taskmaster test ports. 5433, 5422. Docker Compose F. Docker Compose test YML up D. Database URL equals Postgres/test at localhost 5433 taskmaster test. npx prisma migrate deploy. Note, the port is 5433, not Postgres' default 5432, specifically so this container can run alongside your normal dev database without colliding with it. Never point database URL at your real dev or production database for these tests. A bug in a delete test could genuinely destroy real data, and that's not a hypothetical worth risking. Step 2. A test-only Prisma client test, dbts. Import Prisma client from @Prisma client. Export test Prisma as a new Prisma client. Data sources db, URL, Postgres/test, test at localhost 5433, taskmaster test. This client is only ever imported by test files. The app itself never touches it. Keeping the wiring explicit is what makes it obvious, just from the import line. Whether a given file is talking to the real dev database or the disposable test one. Step 3. Clean state between every test. App action/project-integration.test.ts. Import, describe, it, expect before each from vytest. Import test Prisma from @prisma-lib testdb before each. Async ago. Await test prisma.task.delete many. Await test prisma.projectmember.delete many. Await test prisma.project.delete many. Await test prisma.user.delete many. Deleting in this order matters. Tasks and members reference projects, so they have to go first or the foreign key constraints themselves would reject the cleanup. Every test starts from a genuinely empty database, so a test never accidentally passes because of a row a previous test happened to leave behind. Testing against the real schema. Step 4. A real write, not a mocked one. It actually persists a project to Postgres, async. Const user, await test prisma.user.create. Data, email owner@test.com. Full name, test owner. Password hash, X. Const project is await test prisma.project.create. Data, name, launch plan. User ID, user ID. Const found is await test prisma.project.find unique. Where, project.id. Expect, found.name.to-be, launch plan. Expect found.userid.to-be user ID. No mocks anywhere in this test. It writes a real row through the real Prisma client, then reads it back through a second, completely independent query, proving the write actually landed in Postgres and wasn't just an in-memory object that happened to look right. Step 5. Proving the cascade actually works. It deletes a project's tasks when the project is deleted. Async. Const user, await test prisma.user.create. Data, email owner@test.com. Full name, test owner. Password hash X. Const project is await test prisma.project.create. Data, Name, launch plan, user ID, await test prisma task.create, data, title shipit, project ID. Await test prisma.project.delete, where, project ID. Const orphaned is await test prisma.find many, where, project ID, expect orphan.toHave-length 0. This is the exact test that would have caught the cold opens missing on delete cascade before it ever reached production. If that config were absent from the schema, this test fails immediately, loudly, in CI, instead of surfacing 3 weeks later as orphaned rows someone stumbles across by accident. Running integration tests separately. Step 6. Keeping them out of the fast loop. Package.json scripts. Test, vitest run. Exclude, /integration.test.ts. Test integration, vitest run, /integration.test.ts. Unit tests from videos 14 and 15 finish in well under a second and are meant to run constantly, on every save. Integration tests talk to a real database over a real connection, slower by nature, and dependent on Docker actually being up. Splitting the two NPM scripts keeps the fast loop fast, while integration tests still run as their own deliberate step, and always in CI. Recap and call to action. Taskmaster now has integration tests running against a real, disposable Postgres instance. Proving writes actually persist, and cascading deletes actually cascade, the exact category of bug that lives in the schema, and that no amount of mocking could ever catch. Combined with videos 14 and 15's unit tests, every layer of the backend is now genuinely verified, not just assumed correct. Everything so far has tested the backend directly, functions and database rows, no browser involved. In video 17, we open a real one. Playwright driving an actual sign-up and login flow, exactly the way a visitor would experience it.